Okay, so before we go through the first example on spherical coordinates, so basically the main component, okay, so there's three things in spherical coordinates. So rho, so basically rho is a radius or sphere, radius of cone or hemisphere. So basically rho here represent the radius. Okay, so phi, basically the angle that we measure from the x-axis. So it's basically the angle. Okay, the angle that we measure from z-axis. Okay, so theta also angle, okay, but angle on xy plane. Okay, means that the angle at the bottom or at the top of the surface given. So let's take a look at this example. Okay, so if G is the solid bounded by z equal to square root 1 minus x square minus y squared and z equal to 0, evaluate the triple integral. So basically for this question, you can choose either you want to use spherical or cylindrical. Okay, you can use both. Okay, but let's try to solve this one using spherical. Okay, so from here you will get this shape. Okay, so this one is hemisphere since it's bounded by this one and z equal to 0, so that's why we have this surface. Okay, so from here we know that the bottom of this hemisphere is a sphere like this with radius equal to 1. Okay, so from here the range of rho here is starting from 0 up to 1 because of this radius is the radius for this one. Okay, the radius for this one 0 up to 1, so that's why we have here 0 up to 1. Okay, the angle of phi here 0 up to pi over 2. Okay, from here up to here only. Okay, half. Okay, that measured from z-axis, so that's why we have 0 up to pi over 2 here. And then for theta, obviously the whole, right, the whole circle for the bottom of the hemisphere, so that's why we have the range for theta 0 up to 2 pi. Okay, the basic idea to solve the question using spherical coordinates is you have to sketch first. Okay, sketch first and you decide the bounded region that will be considered for that question. Okay, and later you will get the range for each variables that you need. Okay, so that, okay, here, sorry, this one. So basically we have triple integral, right? So our function here in terms of rho, phi and theta here, so this one rho squared sine phi. Okay, let me choose here. Okay, so bigger space, so we have triple integral, right? So a function in terms of rho, phi and theta, so we have rho squared sine phi, so del rho del phi del theta. Okay, so basically this one refer to rho, so this one refer to phi, so this one refer to theta. Okay, so from the question, okay, so basically this one, okay, for theta is 0 up to 2 pi, for phi 0 up to pi over 2 since it's hemisphere. Okay, and for rho 0 up to 1. Okay, so if we take a look at this one, okay, so this one is signed square root, right? So we're gonna replace all those things, so we get in this form. Okay, so after you get the correct limit for spherical coordinates, so you will get the answer here. Okay, so the basic idea is to sketch, to identify the limits first, and then transform. Okay, transform the given integral into spherical coordinates, and then you can integrate easily, as what we have learned previously. Okay, so you can go through this second example. Okay, so previously they give you dv here. Okay, for the second one they give you in terms of the del z, okay, dz dx dy. Okay, so you have to what we say, we have to identify the region based on the given limit in Cartesian coordinate first. Okay, before we convert in terms of spherical. Okay, so I give you together with the picture, so you can go through this example, and later I'll give you tutorial question for spherical coordinates. Okay, so same goes to the previous one. So the application for spherical is volume. Okay, as long as the given function is equal to 1. Okay, so let's say this one is 1, so obviously the one that you calculate represent the value of the surface. Okay, so that's all for spherical coordinates.